This is Victoria Tencio, and this is my submission for Chapter 24 homework. Part A states the two plates of a parallel plate capacitor each have an area of 0.460 meters squared, are 3 millimeters apart, and initially have vacuum between them. A power supply is attached to the capacitor, charging it to 4 voltage, and is then disconnected. A dielectric sheet is then inserted that fills the space between the plates. The potential difference between the plates increases to 2.5 kV, and the charge on each plate remains constant. Find the original capacitance. So the way that we're going to find this is we're going to use the formula for capacitance of a parallel plate capacitor. So this would be C is equal to EKA divided by the distance. So then from here, we just want to plug in. So this is a constant number, which is 8.85 times 10 to the negative 12. So we're going to plug that in here. Times our A, 1 times, and then we're going to add our area, the 4.460 meters squared. And then when we, and we need to divide this by the distance that we were given. So this would be the 3 millimeters, so 3 times 10 to the negative 3 power. And this, when we plug it into the calculator, gives us 1.36 F. So this would be our answer for part A. For part B, we are asked to find the charge on the capacitor plates. So this we can find with the formula Q is equal to our capacitance times our voltage. And then when we plug this in, when we plug the values in, we basically get that. So 1.36 times 10 to the negative 9 times our voltage, which would be 4 times 10 to the third power. And when we plug this into our calculator, we get 5.44. And then we use our units for the charge for Q. So this would be our answer for part B, and then this actually would be equal to 4 times 10 to the negative 6 C. So the answer could be either of these two choices. So for part C, we're asked to find the dielectric constant of the dielectric. So for this, we can obtain this by using the conservation of change before and after insertion of the dielectric slab. So the way that we do this is Q is equal to Q prime. And then from this, Q is equal to CV, to our capacitance times our voltage. And this is equal to K, CV prime. So Kc is equal to the new capacitance, and then the V prime would be the new potential difference. So this would be V prime is equal to V divided by K, and then when we move this around, we get K is equal to V divided by V prime. So plugging these numbers in, we get our 4 times 10 to the third power that we used here for our voltage divided by our V prime, which is 250 times 10 to the third power. And then when we plug this into the calculator, we get 1.6 for our K, for our dielectric constant. So that would be the answer for part C. For part D, we're asked to calculate the new capacitance after inserting the dielectric. So in order to find this, we are going to use the formula of a capacitance prime, which is the new capacitance times K, our constant, times C, the first capacitance. So this would be equal to the constant that we just found, 1.6 times 1.3 57, which is the 1.36 that we found here. You can use either or, but this is just so we can get a more accurate answer, times 10 to the negative 9. And then plugging this into our calculator, we get 2.1712 times 10 to the negative 9f, or alternatively, we can say 2.1712 NF. Both of these answers are correct. Feel free to choose whichever. So this would be the answer for part D. For part E, we're asked to find the magnitude of the induced charge on the faces of the dielectric sheet. So in order to find the magnitude on the faces of the dielectric, we need to use the following formula, which is QI is equal to Q 1 minus 1 over our charge, not our charge, our constant. So this equals to Q, our charge, which was 5.44 times 10 to the negative 6. Was this 5.44? 5.4, excuse me, 28 times 10 to the negative 6, and then 1 minus 1 divided by our k, which is the 1.6 that we found. Just solving this, 5.428 times 10 to the negative 6. This is 0.6 divided by 1.6 when we multiply this, and then we solve that. And then this is equal to 2.035 times 10 to the negative 6c. Or we can also say that this is equal to 2.035. And then these two are equal, so choose whichever option you would like. Mastering physics typically asks for C. So that is the answer for part E. For part F, we are asked, the two plates of a parallel plate capacitor each have an area of 1.20 meters squared, are 0 meters squared, are 4.5 millimeters apart, and initially have vacuum between them. You connect a power supply to the capacitor, charging it to 3.50 kV. Keeping the power supply connected, you insert a sheet of dielectric with dielectric constant of 2.50 that fills the space between the plates. Find the original capacitance. So in order to find the original capacitance, we use the same formula that we used at the beginning, which is E0 Ka divided by our distance. And basically, we just go ahead and plug in. We used our constant 8.85 times 10 to the negative 12 times our area that we're given here is the 1.20 divided by our distance, which is the 4.50 times 10 to the negative 3. And then when we plug this into our calculator, we get 2.36 times 10 to the negative 9 F. And that is our answer for part F. For part G, we are asked to calculate the original charge on the capacitor plates. And we're going to use the same steps that we used for our previous questions, which would be Q is equal to our capacitance times our voltage. And then this is equal to the number that we just found, 6 times our voltage, which is the 3.50. So this would be 3.50 times 10 to the third power. And then when we plug this into our calculator, we get 8.26 times 10 to the negative 6c. And that is our answer for part G. For part H, we're asked to find the new capacitance once you insert the dielectric. So here basically the same formula that we used previously, but I'm just going to go ahead and simplify it a bit. So this would be C prime is equal to KC. And basically this would be our K that we're given, the 2.50, times our capacitance, which would be the 2.36 times 10 to the negative 9 power. And this would be equal, when we plug it into our calculator, 5.9 times 10 to the negative 9F. And this is our answer for part H. For part I, we're asked to calculate the new charge on the capacitor plates. So here, once again, same formulas that we used previously for the previous question. This would be our Q prime is equal to our K times our Q. So our K is 250 that we're given times Q, which we found earlier, the 8.26. So 8.26 times 10 to the negative 6. And then when we plug this into our calculator, we get 20.6 times 10 to the negative 6C. And this is our answer for part I. For part J, we are asked, calculate the magnitude of the induced charge on the faces of the dielectric sheets. So here we're going to use, once again, same formula that we used previously. Ki is equal to Qi is equal to Q0, parentheses 1 minus 1 divided by our K, our constant. So this would be equal to, actually, we're going to use, in order to find this Q0, which we don't have yet, we're going to use the following formula, which would be Q0 is equal to our capacitance 0 times V. And this would be equal to our, this is basically our first capacitance, the 2.36 that we found earlier, times 10 to the negative 9 times our voltage, which is, and it was given 3.50 times 10 to the third power. And then this would be equal to 8.26 times 10. Actually, this, we just basically did the same thing, to the negative 6C. This is where we get our Q0. So then 8.26, just following the same formula, times 10 to the negative 6 is equal to 1 minus 1 divided by our given K, which is 250. And then this is equal to times 10 to the negative 6. This is equal to 1 minus 0. 1 minus 0. 1 minus 0? This is equal to 0.26. 0.26. And then this is equal to, when we plug it into our calculator, 9.56 times 10 to the negative 6C. And that is our answer for part J. Now we're going to go on to part K. With vacuum between its plates, a parallel plate capacitor has capacitance 4.50. You attach a power supply to the capacitor, charging it to 2.80 kV, and then disconnect it. You then insert a dielectric sheet that fills the space between the plates. The potential difference between the plates decreases to 1.50 kV. And then charge on each plate remains constant. Find the energy stored in the capacitor before you insert the sheet. So for this question, we are going to use the following formula, which is U is equal to 1/2 times our capacitance times our voltage squared. So this would be equal to 1/2 times our capacitance, which was given just 4.50 times 10 to the negative 6 times our voltage, which is 2.80 times 10 to the third power squared. Plugging this into our calculator, we get 17.64, and the units for this would be joules. So this is our answer for part K. for part L, we are asked to find the energy stored in the capacitor after inserting the sheet. So for this, we're gonna use the following formula, which is the capacitance 1 is equal to our voltage 1, and then capacitance, our first capacitance times our first voltage is equal to our second capacitance times our second voltage. And then solving this for second capacitance, which is what we're being asked. Well, actually, we're being asked for the energy stored in the capacitor, but this would be equal to C1 times V1 divided by V2. Okay, so then here we're just gonna plug in our values. Our C1, which is 4.50 times 10 to the negative 6 times 2.80 times 10 to the third power, all divided by our second voltage, which is 1.50 times 10 to the negative 6. And then all of this is equal 8.4 times 10 to the negative 6 F. And then what we're going to do is, once again, use the formula that we use for part K in order to find our answer. So this would be 1/2 C times V squared. And this is equal to 1/2 times our capacitance that we just found, 8.4 times 10 to the negative 6, times our 1.50 that we're given, 1.50 times 10 to the third power squared. And all of this is equal to 9.45 J. So that is our answer for part L. For part M, we are asked, with vacuum between its plates, a parallel plate capacitor has capacitance of 5.60. You attach a power supply to the capacitor, charging it to 1.50 kV. Keeping the power supply connected, you insert a dielectric sheet with dielectric constant of 2.35 that fills the space between the plates. Find the energy stored in the capacitor before the sheet is inserted. So for this, we're going to use, once again, the same formula. U is equal to 1/2 our capacitance times our voltage squared, and this is equal to 1/2 times 5.60 that we are given, times 10 to the negative 6 times 1.50 that we're given times 10 to the third power, and all of this is squared, and this is equal to 6.30 joules. So that is our answer for part M. And then finally, for part N, we're asked to find the energy stored in the capacitor after the sheet is inserted. So for part N, the formula we're going to use is capacitance is equal to our constant times our initial capacitance. So this would be equal to the constant number that we're given, 2.35, times the capacitance that we're given. So that would be 5.60 times 10 to the negative 6. And from this, we get 13.16 times 10 to the negative 6F. So now we're gonna circle back to this formula. U is equal to 1/2 our capacitance times our voltage squared, and this is equal to 1/2 times our capacitance that we just found, which is 13.16 times 10 to the negative 6, times our voltage that we were given at the beginning of the question, 1.50 times 10 to the third power squared, and then we get 14.805 joules as an answer for part N. And this is all of the parts for homework 24, and this is exam for chapter 24. Thank you.